So tomorrow you're going to be doing some paper chromatography, and I really enjoy doing paper chromatography because it is a simple yet very effective way to get some qualitative information about what's in a mixture. It's going to separate molecules based on how well they attract a movable phase versus a stationary phase. And we will have plenty of time in class to discuss that, but I want to get to how you actually start paper chromatography, because what you need to do as soon as you get to class and we get started is to set it up so it can develop as we discuss how it actually works. So you can imagine with paper chromatography we need chromatography paper. This is a special paper, not unlike coffee filter paper. But it is cut to a big strip for us, and sometimes the strips are wide, sometimes they're narrow, doesn't really matter. But I'm going to start by making a starting line, and I want my starting line to be about 1 centimeter from the bottom, and check this out, I'm using pencil. Okay, and the reason I'm using pencil for my starting line, here you can kind of see it. The reason I'm using pencil for my starting line is I know that the pencil will not dissolve in my movable phase. That would be an issue. Then I would be separating what's in the pencil instead of, so don't use pen. If the pen were to separate, then you'd get pen interference with what you're trying to separate. Now also on the other side, so I put pencil mark there, on this side is my name. Okay, so I wrote my name on this side. Get it? It says my name. Okay, literally. So I've got my name on this side. There it is. And I've got the pencil mark on this side as a starting mark. And I'm going to now place my sample mixture on my starting mark. So I have purple stuff. And you, of course, you will know in class what we're using. It's going to be a common everyday thing. But I'm going to take the toothpick that's soaking in my purple stuff, and I'm going to use the tip of the toothpick by holding it on the starting line to put a dot. And I'm going to re-dip, and I'm going to tap it once again. So notice I'm not tapping for long, but I wanted to try and get that 2-layer going on. So I got a good amount of purple stuff. You can see the purple stuff on my starting mark there. All right. Now that I've got the starting stuff on the purple on my starting mark, I'm going to size it up for the beaker. Notice the beaker is empty. I'm sizing it up for the beaker, and you could do this before you dot it. Might even be better that way. But I want the bottom of the paper to just barely touch or even float slightly above the bottom of the beaker. So I'm going to wrap it around the pipe cleaner in such a way that it's going to hang barely touching or slightly above the bottom of the beaker, and then holding that in place up here with the paper clip. So your setup should look like this. And see how it is barely resting above the bottom of the beaker. So either barely touching or resting above. What you don't want to do is just ram the whole thing down into the bottom, because crumpled up at the bottom is going to do you no good at all. Notice the beaker's been dry so far. Okay, I'm going to now take my stationary phase out. This is my stationary phase, the paper, and I'm going to add my movable phase. With what we're going to separate, I know it dissolves in water, and when you realize what we're going to be using, you're like, well, duh, yeah, because we use water to mix it up. So I'm going to take water, about 25 milliliters of water, and that is stated in the lab, and I'm going to pour that in. Now I have my movable phase in the beaker. I have my stationary phase right here as the paper, and I'm going to lower the paper in slowly to where it dips into the water just barely. That's what I want. I want it to make contact with the water. I do not want the dot submerged in the water. If the dot is submerged in the water, then it will wash away and you won't get the results that you need to get. And we're actually going to sit here and watch it develop. I'm going to zoom in. You can actually already see some splitting. And it's just going to continue for a while. So if from this point in time you want to fast forward the video and watch it develop, I would recommend that. Just be sure you catch the very end as to what we do to finish it off. So hang out with the video going and I'll let you know when we're ready to finish off, but you can already see how we are qualitatively separating. We're like, oh, in the purple was some pink stuff and some blue stuff. And of course that's not shocking because you're like, yeah, that's what mixes to make purple, but that is definitely what we are seeing. So we're going to watch this develop, and you may want to like sit back and enjoy a cold Mountain Dew or something like that while you wait for it. This is the time in which we would be discussing how this works in class. So feel free to fast forward to almost the end and watch how we need to wrap this up at the very end. Okay, so welcome back. If you were fast forwarding, hopefully you have stopped. I'm waiting to be like, hey, pay attention. Okay. As you can see, even in this short time, we got our purple to separate into blue and red. And, you know, that is not surprising. But here's how we need to finish it off. We're going to get a piece of paper towel. And on our paper towel, we're going to place our wet chromatography paper. And I need to trace how far the water line got. So I'm going to, and I can use pen this time, I'm going to trace how far the water line got just by literally tracing the water line. You can use pencil too, doesn't matter. And then I also want to find the center of the color blobs. So there's like the center of my blue blob, and finding the center of my red blob, I feel it's kind of like right there. Okay, now if we waited longer, more and more of this red is going to be, you know, moving up and up and up, and so it would continue to separate them the longer we give them. But this is certainly plenty for our qualitative work right here. All right, so we have our solvent line marked, we have the center of our blue blob, center of our pink blob. What I need to do now is calculate a thing called an RF, and that is the distance from the start line to how far the center got, divided by the start line to how far the water line got. And since I have two colors, I need two RFs. I need an RF for the pink, and then up here I need an RF for the blue. So it would be the distance the blue dot there traveled compared to the distance divided by, that is, the distance that the water line traveled. And that's how we get this thing called an RF, resolution factor. And all an RF does is references for us how well we were able to separate these. So you can notice a big separation. So a little prelude for tomorrow. Since the pink did not move a lot, it must be more attracted to the stationary phase, the paper, than the mobile phase, the water. And the opposite, since the blue traveled a lot, it must be very well attracted to the movable phase, the water, and not so attracted to the stationary phase. And so we could do this for almost anything that's a mixture of things that we have a movable phase and a stationary phase for. There's lots and lots and lots and lots of types of chromatography. Each one uses a different stationary and different mobile phase because of the type of molecules you're separating. Now before we end, I want to show you this one other thing. Earlier I did paper chromatography for green food color, and you're like, well, if purple is, you know, red and blue mixed together, which kind of makes sense, green should be blue and yellow. Well, here is my green food color. It moved all the way up. And what I want to point out is this is actually, in this particular case, FD&C green number 3. That is what you know of as green food color. If you ever buy the boxes of food colors in the store and you squeeze out of the green bottle, this is what you're squeezing out. This is one molecule. It is not a mix of blue molecules and yellow molecules. There is no yellow molecule because it is just one molecule. Now, I'm not saying you could not mix blue and yellow and get green. Absolutely, but that's a blue molecule with a yellow molecule to make an appearance of green. This is a single green molecule. So this is the coolness, the power of paper chromatography. It told me this is not a mixture. This is a pure compound. This is one green molecule because I got no other separation. If it was a mixture, then I would easily see a blue dot and a yellow dot, and I would do the same RF factors I did over here for a purple. Okay, so that's paper chromatography, and that's what you need to do tomorrow. So you're going to set it up tomorrow with your assigned color. I'll assign you a color. You don't get to pick. And while it's doing this dissolving thing and the water's moving up the paper, we will discuss how this actually works in great detail. All right, so this is our lab for tomorrow. Be sure you have paid attention and are ready to go.